Hello viewers, I Vinod Kumar Chauhan welcomes you in my YouTube channel CQ means Chauhan Coaching Classes. Today we start chapter 10 Practical Geometry. Point 1 Introduction. You are familiar with a number of shapes. You learned how to draw some of them in the earlier classes. For example, you can draw a line segment of given length, a line perpendicular to a given line segment, an angle bisector, a circle, etc. Now you will learn how to draw parallel lines and some types of triangles. Construction of a line parallel to a given line. Throw a point not on the line. Make these constructions using ruler and compasses only. Step 1. Take a line L and a point A outside L as shown in figure first. This is the line L on which one point B is shown there, and one more point A we take outside to L. Take any point B on L and join B to A. Like this, you join the point B with A on line L. This is our step number 2. Now step 3, with B as center. This is your B and a convenient radius as according to you. Draw an arc cutting L. This is L at C. This is C, and B A at D. This is our B A at D. So from your rounder you can take some convenient radius and draw an arc which cut L at C and BA at D. This is our step number 3. Now step 4. Now with A as center, this is our A and the same radius as we take on point B. In step 3, draw an arc EF. This is EF. Cutting AB. This is AB at G. This is our G as shown in the figure 4. Now the step 5, place the pointed tip of the compasses at C. This is our C, and adjust the opening so that the pencil tip is at D. Now the step 6, with the same opening in step 5 and with G as center. This is our G. Draw an arc cutting the arc EF at H. This is EF. Now we are going to start exercise 10.1. Question number 1. Draw a line, say AB, take a point C outside it, through C. Draw a line parallel to AB using ruler and compasses only. So first we draw a line AB. Suppose we take the point D here. First we join D with C. Then with the help of compasses we draw one arc from the D, as taking D as a center. Suppose it cut AB, E and F. Suppose it cut AB at E and CD at F. Now we put our metallic point of our compasses at D and open the rounder from D to F. Now from point C we draw one arc with the same radius as we opened from D to F. Suppose the name of this arc is GH and it intersects CD at I. This is our I. Now again we open our rounder from E to F. We put the metallic point of our compasses at E and open up to F. Now with the same radius EF we put our compasses on I and cut the arc GH at J. It is our J. Now we join J with C. Now this is AB line and this is CJ line. This is CJ line. These two lines are parallel to each other. AB is parallel to CJ. This is the solution of our question number 1, in which we draw a line AB first. This is AB. Take a point C outside it. This is the point C. And through C, from the C, draw a line parallel to AB using ruler and compasses only. This is the CJ line. So AB is parallel to CJ. This is the solution of question number 1. Now the question number 2, draw a line L, draw a perpendicular to L at any point on L. On this perpendicular, choose a point X 4 cm away from L. Through X, draw a line M parallel to L. Suppose it is our line L. Now we choose one point P on this line. Suppose it is here. Now we join P with this intersecting point and then we increase this, so it is our required perpendicular on point P. According to the question, draw a line L. This is our line L. Then draw perpendicular to L at any point on L. So this is the point P and it is the perpendicular on this line L. On this perpendicular, choose a point X 4 cm away from L. So now we open our rounder 4 centimeter, then we put the metallic point of our rounder on this point P, and then we draw one arc on this perpendicular 4 centimeter away from the L, like this. Now we get this intersecting point, and it is 4 centimeter. This point is called the X. First we draw one arc from point X, then from this point again we draw one arc of 60 degree, then from this 60 degree we draw the one more arc of 120, then from 60 and 120 we draw these two arcs. This is the intersecting point. Then we join X with this new intersecting point. This is called Q, and then we join these two intersecting points. So this is the required perpendicular through X. Draw a line M parallel to L. So this is the M line, and it is 4 centimeter away from the L. Now construction of triangles. It is better for you to go through this section after recalling ideas on triangles, in particular the chapter on properties of triangles and congruence of triangles. You know how triangles are classified based on sides or angles, and the following important properties concerning triangles. The first property is the exterior angle of a triangle is equal to the measure to the sum of interior opposite angles. This is the figure 1, in which this is 3 is the exterior angle, and it is equal to the sum of these two interior angles 1 and 2. Angle 3 equal to the angle 3 is equal to the sum of angle 1 plus angle 2. These two angle 1 and angle 2 are the interior angles, and it is the sum of these two angles is equal to angle 3, that is the exterior angle. Now second point, the total measure of the three angles of a triangle is 180 degree. This is our second figure, in which angle 1 plus angle 2 plus angle 3. This is our angle 1, this is angle 2, and this is angle 3. The sum of all these three angles is equal to 180 degree. This is our second property. Now the third property, sum of the lengths of any two sides of a triangle is greater than the lengths of the third side. This is, there are three sides in this angle, side A, side B, and side C. So the sum of side A and side B, that is always greater than the measurement of side C, and it is true for all the three sides. When we add the B and C, then the sum of these two sides is greater than A. When we add C and A, then the sum of these two sides, C and A, is always greater than the B. So this is the third condition, sum of the lengths of any two sides of a triangle is greater than the lengths of third side. Now the fourth condition, in any right angle triangle, the square of the lengths of hypotenuse is equal to the sum of the squares of the lengths of the other two sides. In a triangle, the longest side is always called the hypotenuse, and these are the other two sides. This is called base, and this is called the perpendicular. So perpendicular is equal to the square of the hypotenuse. B square plus A square equal to C square, in which B square is the perpendicular, B is the perpendicular, A is the base and C is the hypotenuse. In the chapter on congruence of triangle, we saw that a triangle can be drawn if any one of the following sets of measurements are given. First, 3 sides, second, 2 sides and the angle between them, third, 2 angles and the side between them, fourth, the hypotenuse and the leg in the case of a right angle triangle. We will now attempt to use these ideas to construct triangles. The first criteria is constructing a triangle when the lengths of its 3 sides are known. This is called the SSS criteria or a triple S criteria. Today we are going to start exercise 10.2. Question number 1. Construct triangle XYZ in which XY equal to 4.5 cm, YZ equal to 5 cm and ZX equal to 6 cm. For this, first we construct XY equal to 4.5 cm. Then we construct one arc from this point Y Z, that is of 5 cm, of 6 cm from this point. Then these two intersecting points that we join, ZX and ZY. First we draw this XY line of 4.5 cm. Then from this point Y we draw YZ equal to 5 cm. For this we open our rounder 5 cm. Then we draw one arc from this point. Now from this point X we draw the ZX equal to 6 cm. We can say XZ or a ZX, no problem. 6 cm. Again we open our rounder 6 cm and then draw one arc from this point X. So now we get this intersecting point of these two arcs, that is called Z. Now we join this Z with X and Y both with the help of ruler and pencil. This is our required triangle XYZ. This is X, this is Y and this is Z, in which XY equal to 4.5 cm, XZ equal to 6 cm and YZ equal to 5 cm. This is the construction of triangle XYZ for the question 1. Now the question 2. Construct an equilateral triangle of side 5.5 cm. In this question only one side is given. The measurement of one side is given, that is 5.5 cm, and we are going to construct a equilateral triangle. A equilateral triangle is a triangle in which the measurement of all the 3 sides of a triangle is equal. It means first, second and third side. There are 3 sides in a triangle and the measurement of all that 3 sides are equal. So that is equal to 5.5 cm. Now we are going to construct this triangle. First we draw the baseline of 5.5 cm and then we draw one arc from this point, that is also the 5 cm, with the help of rounder and pencil. Then we draw one more arc from this point with the help of rounder and pencil that cut the previous arc on this point. So like this we draw two arcs with the help of rounder and pencil, and then we join this intersecting points of these two arcs with this point and this point. First we draw a baseline of 5.5 centimeter. Suppose it is our A and it is our B. Now from point B we draw the one arc of 5.5 centimeter like this, and from point A again we draw one more arc of 5.5 centimeter that cut the previous arc at this point with the help of rounder. Now the intersecting point of these two arcs is our C. Now we join this C with A and B both with the help of ruler and pencil. Five point five centimeter, 5.5 centimeter. AB is 5.5 centimeter, BC is 5.5 centimeter, and CA is also 5.5 centimeter. So this is our required equilateral triangle. Now we are going to solve the question number 3. Draw triangle PQR with PQ equal to 4 centimeter, QR equal to 3.5 centimeter, and PR equal to 4 centimeter. What type of triangle is this? In triangle PQR, the measurement of three sides is given, in which PQ equal to 4 centimeter, QR equal to 3.5 centimeter, and PR equal to 4 centimeter. First we draw the baseline of 3.5 centimeter, then we open our rounder 4 centimeter and draw the one arc from this point. Now we draw one more arc from the next point, from this point, with the help of rounder like this. This cut the previous arc at this point. Then we join the first and the second arc with the help of ruler and pencil. That is QR. Now from point Q we draw the one arc of 4 centimeter, that is PQ. For this we open our rounder 4 centimeter and then we put our metallic point of rounder on the point Q and draw one arc. Now with the same radius 4 centimeter, with the same radius, same length 4 centimeter, we draw the one more arc from this R point that cut the previous arc at this point. Now we join Q with this P. This is our P point. The intersecting point of these two arcs is P. Then we join P with Q and P with R. P with Q and P with R with the help of ruler and pencil. The length of PQ is 4 centimeter and the length of PR is also 4 centimeter. A triangle in which the measurement of two sides is equal, that is called the isosceles triangle. So it is isosceles triangle. What type of triangle is this? This is the second part of this question. So we can say this is the isosceles triangle. Now the next criteria in which we are going to constructing a triangle when the lengths of two sides and the measure of the angle between them are known. That is SAS criteria, side angle side criteria, in which the measurement of two sides and the angle between them is given. Today we are going to start exercise 10.3, question number 1. Construct triangle DEF such that DE equal to 5 cm, DF equal to 3 cm and measurement of angle EDF equal to 90 degree. First we draw the rough figure for the question number 1. Suppose it is our DE of 5 cm, then measurement of angle EDF equal to 90 degree. This is our point D. Here we can draw this one arc, and from this point we draw this two arc like this, from this to this and this to this. Then from this point we draw one arc and again one arc from this point, and then we join with this D. So it is 90 degree. Angle, measurement of angle EDF is what? 90 degree. Angle D equal to 90 degree. Then DF equal to 3 centimeter. So now we open our rounder 3 centimeter and then we put the metallic point of rounder on the point D, and from this D we draw one arc on this perpendicular of 90 degree. This perpendicular on taking the radius 3 centimeter. So this is the arc of 3 centimeter and this intersecting point is called F. So now we join E and F with the help of ruler and pencil. This is the triangle DEF, in which DE equal to 5 centimeter, DF equal to 3 centimeter and angle EDF equal to 90 degree. The measurement of this side is not needed. This we can join with the help of ruler and pencil to complete this triangle. This is the rough figure for DEF. Now we are going to construct the fair figure for DEF. First we draw DE equal to 5 centimeter, and then after we draw the angle of 90 degree with the help of a rounder. This is the arc. Then from this point we draw one more arc for 60 and one more arc from 60 to draw the 120, and from 60 it is the first arc, and from the 120 it is one more arc. Then we join D with this point. This is our angle of 90 degree. Now we open our rounder 3 centimeter, and from the point D we draw one arc on this perpendicular at the distance of 3 centimeter, because we opened our rounder 3 centimeter. So now this is the arc of 3 centimeter, and by intersecting this perpendicular by this arc we get the point F. The distance between D and F is what? That is 3 centimeter. Now we join E and F. Now we join. So this is our required triangle DEF for the question number 1. This is the solution of question number 1, in which DE equal to 5 centimeter according to the question, DF equal to 3 centimeter according to the question, and measurement of angle EDF, that is EDF 90 degree. Now we are going to solve the question number 2. Construct an isosceles triangle in which the length of each of its equal sides is 6.5 centimeter and the angle between them is 110 degree. First we draw the base side. Suppose it is A and this is B. The length of this side is 6.5 centimeter. Now from point A we can draw one angle of 110 degree. So with the help of protractor we draw one angle of 110 degree. This is the angle of 110 degree. One arc on this angle of 110 degree. Suppose it is the arc of 6.5 centimeter. 5 centimeter, AC equal to 6.5 centimeter, and angle A equal to 110 degree. This is the isosceles triangle.